Right. Good evening. Let's start the class. Sorry, I couldn't take the class on last Friday uh, because of a technical issue that I had at the last minute. So I have opened the chat. You can ask any questions. Uh, Unmute yourself, or you can type in your chat window as well. Let me share the screen to start with. If there are any uh, connection issues, just let me know. Okay. Let me share the screen. I need to give the permission here. Right. To start with, I have prepared some questions, but to start with, let's do some organic conversions. Can you try these two? These four conversions. I will give you around 10 minutes for this one. First two has to be done in 4 steps. The last two has to be done in 3 steps. Just let me know once you're done. You can start now. These are very simple things. We will gradually move into the hard questions because you have done only up to some of you have only done up to ketones and aldehydes. I can't give many very complex organic conversions. So these things can be done with the knowledge up to benzene, right? Give it a try, then we can discuss. Once you done, let me know, then we can discuss. I will give you around 10 minutes until 10:15. There's a question in the third one, steric hindrance will affect. Yes, correct. Yes, it will pass into meta. Yes, correct. But for the organic uh, conversions, you can take like yes, it's a minor product. Yes, a minor product. So, yeah. So organic conversions actually you can uh, neglect very. I'm not saying like minor products. So like sometimes you have to take minor products in the organic conversions. Sometimes you have to take major products in the organic conversions because you are going to whatever you want, right? So it should not be an illegal thing, but you have to be smart to select the correct path that you want, right? uh, let's discuss uh, starting from the first one. Okay. uh, I will take this one. C double OH. This has to be converted into CH2, CH2, CH3, and CH3. Uh, so what I shall do is I will remove this double OH group, right? So then I will have a free benzene ring because with C double OH, its minimum number of reactions can be done actually with C double OH. So that's why I'm going to remove this one. To do this one, you can use soda lime, sodium hydroxide, calcium oxide, and really and heating. Then after that, I have a meta director actually in this one. So I will do some acylation first with the required number of carbon atoms. So I can do this acylation. For this one, I can use CH3, CH2, C double bond OCl, and anhydrous AlCl3 while heating. Then I can do some kind of alkylation to attach CH3 bond or CH3 group. It will be directed towards the um, sorry, one CH2. It will be directed towards the meta to here. I can use for this one CH3Cl, anhydrous AlCl3, and while heating. From here to here, you can use Clemenson, Zinc Hg. Hope you have done this one. Concentrated HCl together with heating. Clemenson will do the removal of double bond and addition of two hydrogen atoms. Right? Yes, I have received few answers. Silver silver. Ah, that's good. Yeah, use magnesium, right? I thought you haven't done this method actually, like aldehyde addition with MGBR. I thought that you have not done this one first, but yeah, if you have done this one, that's great. then I can use that part as well. Second one is also correct. Actually, for the second one, uh, this is Kavija, right? Yeah, Kavija, for the second one, Clemenson cannot be used for uh, C double OH groups. It only can be used for aldehydes and ketones, not for carboxylic acids, right? Yeah. Okay. Clemenson is only for aldehydes and ketones. That means the Clemenson means this one, this region, only for aldehydes and ketones. This is only for aldehydes and ketones. Okay. Right. The second one, this is a bit tricky actually. So CH3, this should be in NO2 position. So there are many methods to do this one actually. So I will convert CH3 into C double OH by H plus MnO4 addition. You know, the benzene cannot be oxidized. Benzene is very resistant for the oxidation. Even with strong oxidizing agents like H plus MnO4 minus ions, benzene cannot be oxidized. But when it is added with CH3 group, it can be oxidized. Only the CH3 group will be converted into C double OH group, right? And C2H C2H5 is also can be converted into C double OH group with uh, H plus MnO4 minus ions, but not the benzene ring, right? What I want to tell you is this one is also possible. I think I have discussed this one in the previous class. This is converting into H plus MnO4 minus ions. This is also converts into CH3 actually. Sorry, C double OH. So one carbon atom is also released with this one. Okay. This is also something that you need to remember. This is in some books, this is used, right? Then I will remove this one, C double OH group, by using soda lime. Soda lime is sodium hydroxide, calcium carbonate, sorry, calcium oxide, very sorry, calcium oxide together with heating. Then I will add NO2 group here with concentrated HNO3 plus concentrated H2SO4. Then I can do acylation by adding CH3Cl and hydroClCl3 together with heating, right? So this can be done in these 4 steps, this conversion, okay? And the third one, yeah, this one. This is also something very interesting one. Cl converts into DCH2CH3. You know, even though chlorine is deactivating the benzene ring, it is auto-para-directed. That is something we need to remember, right? So I can do alkyl acylation by adding CH3CH2Cl together with chlorine. Then this will be going into the para position like this. Then it's a matter of addition of D. D means deuterium. I have introduced you this one. So I can add magnesium dryether. Then this will be converting into magnesium Cl and CH2 CH3, and you can add D2O for this conversion. Quite interesting one. But as you said, like this will impact some uh, meta detector as well, but yeah, it will be as a minor product actually, right? Okay. Then the next one is benzene is converting into uh, quite interesting one. Here this is NO2. Then in the meta position we have CH2 and a benzene ring. So what I can do is I will first add HNO3, concentrated HNO3 and concentrated H2SO4 to add NO2 group. Concentrated HNO3, concentrated H2SO4, and together with heating, then I will have NO2 group. Then I will do Friedel-Crafts acylation, right? Friedel-Crafts acylation can be done with something like this: anhydrous AlCl3 together with heating. Then I'm having something like this. NO2 will be here. The next one will be directed to the meta position, relative meta position. So it is this one, like this. And this is a ketone actually. You can apply zinc Hg, concentrated HCl to add two hydrogen atoms. So to convert double bond O, C double bond O into CH2. This is actually 2016 question. One of the 2016 question. මේක නිකන් දැක්ක ගමන් ටිකක් විතර වගේ පොඩ්ඩක් අප්සෙට් ගහනවා මේ කොහොමද කරන්න කියන එක, but it's a very simple one, right? The Craft can do marvelous things in the organic conversions, right? Okay, right. Can you do this question? මේ ගාන හදන්න පුළුවන්. This is a very interesting question. Copy this down and try to do this one. This is the this is A bulb. This is A and this is B and this is ethene. I think it's not seen clearly. Ethene. Adalala කියන්න බෑ. There are a few assumptions that you have to make during this question actually. Otherwise, you can't do this question without the assumptions. There are two assumptions, two key assumptions that you have to make. Gana, do wonder. Right, we will discuss this question actually. Okay, let me see. Correct. Mm, තුන් තුන්වෙනි පාර්ට් එකට නිකන් හරි අතරේ පහේ පොඩි එකක් තියෙනවා අර the problem is with the approach actually. Mm, yeah, we will correct that one. That's okay. Anyway, good try. We will yes, I will discuss this one. Like we have two bulbs here. One is with N2 and other one is with ethene. So V is 10 cubic centimeters in A. Pressure is same in the both directions and temperature is different 127 and 27 degrees Celsius. Now this question, the interesting thing is tap is open and temperatures of both bulbs are remain unchanged. That is the important thing. Temperatures of both bulbs are remain unchanged. Find below. So this is bit tricky because of this one. Now imagine what will happen when we open the tap. So gases will mix together and temperatures are kept same as initial stages. We have to make two assumptions actually. The N2 and ethene behaves ideally. The other one is they are evenly, mixed evenly. The concentration of ethene is not high in B and not high in N2. Concentration of N2 is not high in A. All are mixed evenly. That is also another assumption that we have to make, right? And also this is a closed system. So before and after open the tap, number of moles will be the same because we are not adding anything from the outside or the inside things are not going outside. So that is also some other thing that we need to remember during this question, right? Now the first thing is 18 moles at the initial stage. Now let's try to find 18 moles at the initial stage. Now, uh, since we assume that ideal gas scenario, we have to mention that one. Assuming ideal gas behavior for both N2 and ethene, right? So number one, we can apply PV equals in RT to B bulb. P is 1 into 10 to the power 5 pascals. V here this is 5 cubic meters. N that is ethene that we need to find. R is 8.314 joules per moles per Kelvin, not kilos. And temperature is B 27 degrees Celsius, that is 300, right? So we can find N ethene from here, right? So let's try to get the final answer for this one. So ethene, then the number of moles of ethene will be, if I give you the answer, that is around the pressure is 1 into 10 to the power minus 1 into 10 to the power 5. So let's try to calculate this one. 1 into 10 to the power 5 into 5 divided by 8.314 into 300. So this answer is yeah, this is around, I will give you the answer actually, 200.45 moles. Yes. Number 2 is N2 moles at the initial stage, right? So also we can apply PV equals nRT. මන්දුන්න උත්තරේ මේ වැරදි නම් method එක මේකයි එහෙම ඔලුවට දාලා, right? So PV equals nRT for A bulb. So the pressure is again 1 into 10 to the power 5 pascals. Volume is 10 cubic meters. Na are 8.314 joules per moles per Kelvin, and temperature is 400 Kelvin. 127, no? So that is 400 Kelvin. So Na or N nitrogen, we can find this to be as, I will give you the answer, 300.7 moles, right? Now the next one is, we have been asked to find total number of moles in two bulbs. So even after opening the tap, total number of moles will not be changed. So in total will be equal to Na plus N18. This is 501.15 moles. Right. So this is the total number of moles. This will not change even after opening the tap. The ඊළඟට තමයි මේ ප්‍රශ්නේ තියෙන හොඳම part එක තියෙන්නේ. හරිද? The next question. Final pressure of gas mixture at B. Now, after opening the tap, we don't know how much of moles in B and how much of moles in A, right? But we know total number of moles of A and B will be 500.15, which is what we have found, right? So let's assume that after opening the tap, number of moles within B, the number of moles in B will be consist of N2 and ethene both, because it is mixed now, right? And mixed evenly, right? Now let's say let's assume after opening the tap, number of moles in bulb B is NB. Oops, sorry, NB. Therefore, NA will be 501 minus 15 minus NB. Sorry, 500.15. That is 0.15 minus NB. Then, what is the other trick that we have to make in bulb A and B? After opening the tap, can you understand the pressure in A and B is same? It should be the same, right? Temperature is not changing. Temperature is constant, but opening the tap will create the same pressure, right? It is something that we know from the all-level knowledge. Then what I am doing is, I am going to find this NB by equating the pressure of the both A and B by using PV equals nRT, right? So what shall I do is, again I am applying PV equals nRT to both bulbs. In this scenario, bulb A and bulb B both will be same. The pressure will be same, right? So let's say that is P2. The volume will be 10 cubic meters. This is for A, right? So number of moles we have calculated to be 501.15 minus NB, or T is 400 Kelvin in this one. For B, that is also P2. 500 cubic meters. Here this is NB, R now 300 Kelvin. So this is the third equation. This is the fourth equation. So what shall I do is I will divide 3 by 4. Then I can have P2 10 divided by P2 5. 501.5 minus NB into R into 400 Kelvin divided by NB R into 300 Kelvin. So here P2 will be cancelled off, right? R will be cancelled off. Then you can find an answer for NB Putta. This is the number of moles in bulb B, right? So now you can, we have been asked what is the pressure, find the pressure of gas mixture at B, right? Now let's take this NB value and substitute it to number 4. Then you will have the partial pressure of, or the, sorry, not the partial pressure of B inside the partial pressure of, pressure of bulb B. You will have the answer, right? So you have to find this NB, let's say the value is X. So what I do is apply NB equals X to number 4. Then I will have the answer P2 5 equals NB, you have the answer R and T 300 Kelvin. So you will have the answer is P2 in this manner. Any questions on this one? Right. Then the next part, number 5. Number 5 is we have been asked partial pressure of ethene in A bulb. Then you know, if you know the mole fraction, right? If you know the mole fraction, you can find the partial pressure if you know the total pressure as well. Now, if you consider only A bulb, the pressure is P2, which is equal to the P of bulb B as well. Now, if you find the mole fraction of total mixture or the total system of ethene, and if we assume that ethene and N2 is mixed evenly, the same mole fraction of the total system should be applied for bulb A as well. Can be applied for bulb A as well. If you make a vendor question, so the pulwa or some use color theory. This will be used for Raoult's law in equilibrium, right? But here it is used. What we can use is find the mole fraction of the total system, and it can be applied for each and every position, each and every system of the total system, or the subparts of the system. It can be applied, right? So what shall I do is, and if you know the mole fraction and if you know the total pressure within A, then it would be the ethene mole fraction, right? So what I can do is I'm find X ethene, right? This is N ethene divided by N total. N ethene, you know, we have found it here. This one, 200. This is right, 200. This is anything, and this is in total, right? So this is 200.45 divided by total one is 501.15. So this is the mole fraction, and partial pressure of ethene will be equal to P2, which is the total pressure within bulb A into ethene. This will be the partial pressure of ethene, right? So this is something very interesting question. This this is one of the questions from my model paper as well. One of my model paper. කරපු model paper එක. මේ ප්‍රශ්නේ ටිකක් අලුත් ප්‍රශ්නයක් විදිහට ගන්න පුළුවන්. Right? So ගන්න හදාගන්න බැරුණා නම් I will give you some time. Any questions on this one? මම recording එක දෙනවා. අපේ මේක free of charge class එකක් ඕන කෙනෙකුට join වෙන්න පුළුවන්. I will be sharing the recording and you can share the recording with your friends as well. එක refer කරන්න පුළුවන්. And අපේ class දෙකක් තියෙනවා Friday 10 pm and Tuesday 10 pm. Tuesday 10 pm mainly focusing on organic chemistry and chemical calculations, but it's a mixed exercise. Friday is also mixed exercise in organic cation analysis, organic conversions, everything that you have done up to now in your theory classes will be discussed. The questions will be discussed in our classes, right? Right. So I will give you some time for this one if you need some time. Now, උත්තර එවපු අයගේ වැරදි මොනවද කියන එක තේරෙන්න ඕන. එතකොට try එක හොඳයි, but අර සමහර තැන්වල එවල තියෙන දෙන්නගේ approach හතර පළවෙනි දෙවෙනි ප්‍රශ්න දෙක හරි, තුන්වෙනි ප්‍රශ්නෙත් හරි. හතර පහේ අර approach එකේ පොඩි ගැටලුවක් තියෙනවා. theory එක ඔළුවට වැටෙනවම හරි ඒක. Right. මේකදී අපිට ඉගෙන ගන්න තියෙන in here, if you open the tap, the total pressure will be the same, or the pressure will be same in both the system, and the other one is the system will be evenly mixed. The gases will be evenly mixed, and the mole fraction at any position of the subsystem of the system will be the same. Right? Those kind of things can be applied. Right. Hari. මම මේ guarantee group එකට මම දාන්නම්. ඔයාලට මම කියවන්න මේ guarantee එක මම අද meeting කරන්න හිටියේ අතරම, but time has gone now. I will share you these questions in the group. Meeting අපි ලබන සතියේ කරමු එහෙම වුණා. Right. So our not next week. We'll do the class on the Friday, right? So on the Friday we can continue the class with these questions. I will share these questions in the group. Then we can discuss these questions in Friday. And Friday until 12:30 විතර වගේ වෙනකම් කරනවා. Tuesday class only for 1 hour. The Friday class to 2.5 hours, and it will go on with the time. Okay. So hope you have learned something out of today's class. Invite your friends as well. Then we will meet on Friday. Right. Thank you. Good night. I will show you the recordings as well. Okay.